Good morning, students. Myself, Krishna Kishore. I am Department of AML and my designation is Associate Professor in St. Martin's Engineering College. Here I am going to discuss about computer graphics. In computer graphics, we are having to discuss about translations and transformations. In transformations, we are having to perform many of the operations. In previous sessions, we are discussing about output primitives. In the output primitives, using of an output premise, you are creating lines and curves and polygons. Using of this everything, you are creating the objects. You are creating an object, and you have to perform many of the operations. In the using here, you have to perform the sequence of operations can use into the transformation functions. The transformation functions, we are having a different type of transformations are there. In the different types of transformations, two difference are there. One is basic transformations and another one is other transformations. In the basic transformations, we are having a translation operation is there, and a scaling operation is there, and rotation. And one more is other transformations are sharing and reflection is there. The sharing and reflection. Using of these transformations, you have to perform the object motion. Why you have to perform the object motion? The object motion, if you are doing any animation sequences, it is very crucial point. If you are creating an animation, the object is moving to one place to other place. In that situation, we are using a operation as a translation. And one more is a rotation. If you want to create you have to rotate an object into the different directions. Sometimes not an object, we are taking as our humans as an object. In that object, you have to give an action of a particular human. Then you have to perform the operations. Then sometimes it will be showing as a front face, and sometimes it will be showing as a back face of an object. Then only you are using into the rotation. Here, the one more operation as a scaling operation. The using of a scaling operation, you have to perform either alter the size of an object or decrease the size of it. Using of a scaling operations, these are all the operations he has to perform. Then geometric transformation, and other transformations are sharing and scaling. The sharing is, it will represent the inclination of an object or some distortion of an object. Sometimes you are creating the object as a shadow, and sometimes you are creating the object as some of the distortion object. At that time, we are using into the sharing operation. And the scaling, you are having a scaling is there. In scaling, you have to perform the object based upon the scaling factors only. Here, we are going to discuss about any transformation operations. Different type of any transformations are there. Different type of any transformations are. Then the first one is, you have to take as an operation. The first transformation operation is translation. Translation operation. This translation, it will to perform the object. If you are taking as any object, or if you are taking as any point, if you are taking, you can moving the operation. For example, I am to assuming as one point. If you are constructing any point, it will be required two coordinate points. That is an x coordinate and y coordinate value. If you are constructing any point, you need to require two coordinate points, that is an x coordinate point and y coordinate point. You are constructing a point. Using this point, you have to perform. Here, initially, you are performing the x-axis and y-axis are there. Here, initially the point P1, it is an original position of a particular location. I want to translate the object into the one position to the other position. Here I am giving this some distance. The new distance is new point P1 bar. It is a P1 bar. Here you need to observe the original position of a P1 is here, and the new position of a P1 bar is here. Here we need to identify. Then we have some distance is there. Then the distance we are called as a distance in translation distance. The distance we are called as a translation distance. The translation distance, it will identify, it will be gives how much distance you are moving the object in the way of x-axis and y-axis. How much distance we are going to the object as moving into the direction, either x direction or y direction. Simultaneously it is going to perform a both directions x and y directions only. Simultaneously it will perform into the both directions x and y directions only. For example, we are taking as a point is over. If you are, it will have a line. It will have a line. If you need to construct any line, it will require a 2 points, that is a P1 and P2. That is a 2 point. You have to construct a line. Here, the x and y axes. Here I am giving the point value, the translation distance. If you are moving the point or line or moving in a particular direction, that is I am giving the translation distance Tx. If you are moving the object into a translation distance in Tx, then you have to give the x value only. You have to give the translation distance x value. If you are moving the object into the y direction, then you have to represent a translation distance as y. Translation distance as an y only. Then based upon these two factors, the object is moving into the either x direction or y direction. Here we are having an example. If I am taking as an example, initially I am taking in x and y values are x equal to 2, 2 and x and y values are 2, 2 and 1, 1. It is a point P. That is a point P1 and I am taking as one more point as a P2. One more point as in P2. It will have the point values are x1, it is an x1, y1 and x2, y2. Then here the values are, I am giving the values are P2 as an x value, x2 value equal to 4 and y2 value equal to 5. Here we need to perform this operation. We need to write a one matrix representation form and formula also is there. In translation, if you want to perform any translation operation, then x bar equal to x plus tx. X bar equal to x plus tx and y bar equal to y plus ty. Here I am taking an example of P1. The P1 is the values are 2, 2. P1 values are the 2, 2 and P2 values are 4, 5. Here we need to find out the new x bar value and y bar value. Then the new x bar value equal to the x value, how many it is an x bar in the P1 bar x value equal to 2. That's why we are given the 2. Then next here you need to identify Tx. Then the Tx is given the value of a translation distance. The translation distance, we are transferring the object in a x direction. For example, I will give a Tx value equal to 2. Tx value equal to 2 and Ty value equal to 3. It means the object is moving in x direction 2 unit intervals and the object is moving the Ty in 3 units of an intervals. Here we need to find out an x bar. We are giving the value of an 2x bar is equal Tx equal to 2 and y bar of an already the y value is existing y value equal to 2. Then I will give in a ty value is 3. Then the finally you are getting the new points are 4, 5. New points are 4, 5. Using of these 2 points, we are getting the x bar value, x bar and y bar of an P1 only. X bar and y bar of an P1 only. Then again you need to find out the one more point P2 bar. P2 bar. The P2 bar, the x value equal to initially you are giving the 4 and the translation distance in the second point also I will give in the translation distance of an Tx equal to 2 only. Then the value of 6 and in y bar equal to the y value equal to 5. Y value equal to 5 of a 0.2. Then translation distance is 3. I will give an 8. Then the new points are, we are finding the new points are 4, 5 and 6, 8. 4, 5 and 6, 8. If you have to perform any operations, first you need to give a scaling operation, scaling performations 1, 2, and 3, and 4, 5, and these are all the values. Y direction 1, 2, 3, 4. Initially I am taking this one. After performing, it is in the original position of an object. Then after that it will be moving, it is going to be moving to the 2 units of an x direction. Then the point is starting here. In x value equal to 4, 4 comma 4 only. That is the value of, it is the point P bar, P1 bar. It will have a 4 comma 5 in the y direction of any 5 only. Then next one P2 bar is equal to 6 comma 8. In 6 comma 8 means it is in y direction, x direction is 6 and y direction is in 8. 6 comma 8 only. Then you are performing it. Here we are observing a one point. It is an original position of an object and it is going to be transferred in a particular distance, that you are giving the distance values tx and ty values only. Based upon the tx and ty values, we are shifting the object. It is for the translation operation. And one more next object as next operation is scaling operations. Next one is scaling operation. Then the scaling, using of a scaling operation, you have to perform either alter the size of any object. Here already I told you the translation, in translation the it is depends upon the only the translation value only, translation distance. Either you are giving the translation distance or x direction, or you are giving the translation distance as a y direction only. Here we are giving the matrix format of an P. Initially you are taking as a P, it will contains x and y values. It will contain an x and y values. Then the t equal to, it will have a tx and ty. Tx and ty. We are going to find out a p bar. It will have a matrix representation. You are using the column matrix representation form, x and ty and y plus tx and ty. Based upon these values, you are finding the new points. Here you need to write down, it is a column matrix representation, is normal matrix representation. We are going to write a p bar equal to p plus t only. P bar equal to p plus t only. Here t is the translation distance. Translation distance. If you are performing any operation, if you are performing any movement of a particular object, you are transferring the object in one position to the other position, it is a required point. The t is a major point. It will have to play a major role into the translation operation. Then the next we are going to discuss about a scaling operation. Then the scaling, we are adding, already we are told that the scaling, it will be alter the size of any object. The scaling, it is alter the size of any object. Scaling, it is alter the size of any object. Here it is the majorly depends upon the scaling factor S. Scaling factor. The scaling factor, it will represent how much size you are going to be increase the size of an object, how much size you are going to be decrease the size of an object. Here we are having a conditions also is there. Different type of conditions. First, initially you are taking as a scaling, if you are assuming as one line, you are discussing only the x coordinate value and y coordinate values. We are discussing about any x coordinate value and y coordinate. Initially, I am taking as an object. I am taking and it is an original size of an object. It is an original size of an object. I want to increase the size of an object. I want to increase the size of an object. Then you have to give in a scaling factor value. Then you need to give in the scaling factor values. Scaling factor value. It is the scaling factor value, it depends upon the increase. Here we are having the scaling factor s. The scaling factor s, it is less than 1. Less than 1, the object is going to be decreased. The object is going to be decreased. The scaling factor, it is greater than 1. Greater than 1. It means you are given the in symbol less than 1 and greater than 1. Then automatically the size of object is increased. Here we are going to have one doubt. Then the scaling factor, okay, if you are taking as the scaling factor is less than 1, okay, and if we are going to be, it is a decrease. If it is greater than 1, it is going to be a decrease. If the scaling factor, sometimes if the scaling factor is both the values means if you are taking a scaling direction of Sx and Sy, the both the directions of scaling factor Sx and Sy, both are equal to 1 only. Both are equal to 1. So already, sir, you have told me that the scaling factor is less than 1, you are decreasing the size, the scaling factor is greater than 1, you are increasing the size of an object. What about this situation? In this situation, the object is in no change. The object is in no change. Or if the greater than 1, the scaling factor, if it is Sx and Sy, it is greater than 1, the both and Sx and Sy values greater than 1, the both Sx and Sy values are more than one value. It means, for example, I am taking as an Sx equal to 2 and Sy equal to 2. Here the condition, you have to verify the condition, it is greater than 1, then automatically the object going to be increased, then the situation we are called as a uniform scaling. Uniform scaling. Then the situation we are called uniform scaling. Then here we are taking as an example, and we need to find out the matrix representation form. In the scaling, it is majorly it will performs the alter the size of object. Alter the size of an object. Then what it will be depends? It will depends on scaling factor. Scaling factor depends on the scaling factor. Here we need to find out. Well, initially we are taking an initial point. Initial point or line. We are taking an initial point or line. Then it is a object. It is an initial point. I will take it as a line 2, 2 and 3, 2. Here the point P1 as 2, 2 and point P2 as 3, 2. Then you have to construct 1, 2, 3, 4, 5, 1, 2, 3 and 4. Then the first point, it is 2, 2. Every time you need to construct an x and y directions of a graph, it is very easy to identify. Bar 3, in the 3 is an x value and y is an 2. Then it is an line. Here I am giving the Sx value. Sx value equal to 2 only. Then the Sx value equal to 2. Here we are finding the x bar and y bar value. How you are going to find out the x bar y value? X equal to x bar equal to x into Sx. X bar equal to x into Sx and y bar equal to y into Sy. Here I am giving only the Sx value only. Here I am giving the only the Sx value means it will be changes the size of an only the x direction only. Then the initial point of an x equal to 2 into, then you are going to find out the value, find out a new value of an x bar and y bar values. Then x bar equal to x value equal to 2. It is a point P1. 2 into. Then I will give a Sx value and then scaling factor value, it is only 2. I am giving the scaling factor is 2. Then it is going to be 4. It means the point y bar equal to y into sy. Y value is 2 and I am not giving you any y value, then you are going to take is 1, then 2. The new points are 4, 2 only. New point is 4, 2 only. Then next you have to take as one more point as x bar and y bar. The one more point is 3 into 2. 3 into 2 and y bar equal to 2 into 1 only. 3 into 2, 6 and 2 into 1, 2 only. Then these are all the new point values. 4, 4, 4, 2, x equal to 4 and y equal to 2 only. X equal to 4 and y equal to 2. And one more point is x equal to 6 and y equal to 2 only. Then it is a line. Here we are observing, previously it is the size of any line. It is the size of any line. And the new one is, it is going to be changed the size of an line. Here are you observing, it is the size is, previously it is the smallest size, now it is going to be increased. Then it means you are identifying, previously you are given a size of an object as some small thing, then automatically it is going to be increased. Here it is a line only. If you are taking as any 2D object, if you are taking as any either triangle or square or rectangle, it is easy to identify, you can easy to identify the situation. Here I am taking as an example as one rectangle, then the points are, x point is 2, 2, the point A and B, C and D. First point, A point is 2, 2 and B point is 2, 4 and C point is 4, 4 and D point is 4, 2 only. D point is 4, 2. 1, 2, 3 and 4. 1, 2, 3, 4. Here I am in this problem I have given a Sx value equal to 2 and Sy value equal to 3. Sx value equal to 2 and Sy value equal to 2. How do we are finding the new point values x bar and y bar? Then how do we are finding the x bar value? X bar value of x into Sx and y bar value equal to y into Sy. X bar value equal to x into Sx and y bar value into s into y. Here I am taking the points are initial point. For example, first I am finding it is an original point of in A. Then I need to find out the new A bar. The A, it will contains the x value equal to 2 and into Sx. I will give a Sx value equal to 2. Then here A of x bar and A of y bar, it is equal to 4 and y value also 2 into, I will give an sy value, sy value equal to 3. Then it is going to be 6. Here the new points of A bar, new point of an A bar is 4, 6. New points of an A bar equal to 4, 6. And next you need to find out the B bar value. Then the B bar value also, find in the B bar of x equal to, we will take as a value of 2 into 2. It is 4 and y value equal to 4 into 3. 4 into 3, then it is 12. Then the new points are B bar equal to 4, 12 only. B bar of new value is equal to 4, 12. And then you need to find out any C bar value. C bar of x equal to, then the C bar of an x, the x value equal to 4 and Sx value equal to 2. Then it is going to be 8. Then the y bar value, you need to find out an y bar of an C. Then here the y value also, y bar value 4 and x value, sy value equal to 3. Then you are going to find it is an 12 only. Then the next one is you have to find out any d bar value. D bar of x equal to, the d bar of x value equal to 4 and sx value equal to 2. Then it is an 8. Then the y bar equal to y value of any y value. And then 2 into 3, it is 6. It means the original point of an 2 comma 2 and new points of a bar and b bar and c bar and d bar all the a bar equal to 4 comma 6 and b bar equal to 4 comma 12 and c bar equal to 8 comma 12 and d bar equal to 8 comma 6. Then you need to draw a new graph using of these new values. You need to identify if the size of an object has increased or not. You can verify that one. You are drawing a object. Then you need to find out the new position of an values. Then here you need to take the graph values 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 6, 7 and 8. Here the new point 4 comma 6. In x direction it is a 4 comma 6. It is a new point value 4 comma 6. Then next one is 4 comma 12. 4 comma 12 and next one is 8 comma 12. 8 comma 12 and one more is 8 comma 6. These are all the points you have to identify. Here you are changing the size of an object. Then these are all the transformations functions are there. Using of these transformation functions, you have to perform a multiple type of an operations, the sequences of operations. In generally, in a computer graphics or not in a computer graphics, any animation techniques, you need to perform the using of these transformation operations to perform. You can change the size of an object or you have to move the object one position to the other position. Then you have to apply some of the rules. Then simply you have to change the position of an object. Change the position of an object, you need to transfer you are using a translation function. The translation functions, it will be depends upon the translation vector only. Then here you are calling as a translation function, translation distance, your one more name as a distance vector or shift vector. Then the next one is scaling function. The scaling, using of a scaling function, you need to perform in the operation as you can increase the size of an object or decrease in a size of an object. It is depends upon the scaling factor. The scaling factor, it will have two conditions. One is if the scaling factor value is less than 1, the size of an object is decreased. The scaling factor is greater than 1, the size of an object is increased. If the scaling factor both are same, the scaling factors both are same, the object is going to be changed into the uniform interval, uniform the size. Then if the scaling factor is one scaling factor is sx equal to 1 value and sy value equal to 1 value, then the factor is automatically the object is in different changes. And one more is a rotation. The rotation, using of a rotation, you have to perform the object rotated in different directions. Here we are having two types of rotations are there. One is clockwise rotation and anti-clockwise rotation. Based upon the requirement of a particular application, you are rotating the object into the particular direction. Either clockwise direction we are using into the rotation angle. The rotation depends upon the axis point, either x-axis or pivot point or different type of an axis. So one more is shearing factor. The shearing factor, using of a shearing factor, you need to discharge an object into the x direction or y direction. It is depends upon the x and y values only. And one more is a reflection. Using of reflection, we are creating a mirror image of an object. So the two people have a doubt about it. In rotation also you are performing the same thing. In the reflection also you have to perform. But in rotation, you are performing in a particular direction, particular rotation angle only. And remaining, if you are taking as a reflection, the object, it is going to be rotated into the 180 degrees. Based upon the rotation angle, you have to perform the operation. These are all the 2D transformation operation. Using of this operation, you have to perform a multiple sequence of any operations. These are, if you are given any doubt, you are going to give any information or give it to the mail to the SMEC AC DOS. Using of these information, you have to provide the, if you are having any doubt, given any dkrishnakishore.aml, given SMEC, can give any feedback, you have to provide that based upon this information.